Here we have another important framing member up in the attic. This is where two roofs come together, and this is called the valley.
Welcome back to RGB Custom Builders construction series. Today we'll be going over the frame, and with us today is the founder of RGB, Bob Brown.
Thanks, Sam. So today, as Sam said, we're just going to go over a couple of basic things in the framing. We had a couple of questions as to certain things, and we thought we would go over them in a quick video. It was 39 and a half years ago when I framed my first house, and probably I framed my first 35 or 40 houses. So back then I used to build everything myself. So we'll go over some of the basic elements of framing, and let's start in the basement. So we're actually down in the crawl space of this house, and so you have the foundation, and then at the top of the foundation you put in what's called sill seal, and that stops any drafts from going underneath the plate, in between the plate and the top of the foundation, and fills any gaps that may be in between there. On top of the foundation you have a pressure treated plate, and then from there is where all of the wood framing goes up from. So on top of the sill plate are floor joists, and the floor joists as they go in are crowned. You always put the high point of a piece of lumber up so that when it goes in place it'll settle down to be straight. In the center of the floor joist, typically what you do is you put cross bridging, and that stiffens up the floor. So typically what we like to do at RGB is make the floor joist a bigger piece of lumber. So what happens ultimately is that the floors are stiffer than if you used a code minimum size. The main beams are held up by concrete filled lolly columns. These floor joists in this house are 2x12s, and they're sized that way to make the floor stiffer. Okay, on top of the floor joist that we talked about a minute ago, we put plywood. So this is Huber flooring, and it has a 50-year warranty not to delaminate. And we always glue the floors down first, and then we nail it every 6 inches. On top of the deck box, we build our walls. The exterior walls are made out of 2x6, so you have more room for insulation. Well, those studs are 16 inches on center. And then when you have a high wall, it's always important to have a solid stud from the base all the way to the ceiling, if at all possible. Just makes the walls a lot stronger, and in case you have any high winds, you won't have any issues. So normally you have the walls that have studs 16 inches on center, and then wherever you have a penetration in that wall, for example, there will eventually be a window here, or it could be a door or a fireplace. What you have to do in order to support the load is you install a header, and then you put jacks that support the header. And then wherever you have point loads and a lot of weight come down, you have to support that somehow. In this case, you didn't want to have a wall here, and so you have to put a large beam like this. This is an 8-inch by 15-inch LVL that'll support a lot of the weight from the roof. In this case here, you don't want to put a wall here because this will be in the middle of the kitchen or a post. So what you do is you have one beam supporting another beam, and you have a large Tico hanger that will hold everything up. And this is actually going to be the kitchen, and so what we do is we put solid bridging in wherever the cabinets are going to be attached to the wall. This way, no matter where you put a screw to hold the cabinet, it's going to hold fast. Here we have what's typical framing is a single lower plate and then a double upper plate. And then we always line up the studs with the floor joists above, just to carry the weight better. You can't quite see it now, but the top plate overlaps the outside walls and the interior walls, and it ties all the top plates together, make a nice strong wall. Typically, the interior walls are 2x4 walls, unless indicated differently on the plan. Sometimes you would make it a wider wall on the interior walls just to hide beams and just make it a more uniform look. And that's as opposed to the exterior walls that are 2x6, as mentioned earlier, for the insulation. So here we have the wall that's in between the garage and the house, and those walls are 2x6 as well, so that we can get the insulation in there. And then when we have applications where you don't want a wall and you don't want a post, they make all kinds of material such as these. These are I-joists that span a greater distance than a nominal piece of lumber would do. We also have some beams in here. There'll be a supporting wall up above that'll support some of the roof load, so we put in a stronger beam that'll carry all that weight. The I-joists are used so that we don't have a beam and a post. A lot of builders will do that, and they'll save several $1,000s in order to not have the I-joists, but then you have that post that you're opening your car door into for the rest of your life, which is obviously not ideal. You have a wall that is higher, you always want to put fire blocking, which is a horizontal piece of 2x6 in the wall, so that in case a fire ever started here, it wouldn't go all the way up the bay and spread the fire. I'm currently standing on the landing where the stairs will wind up, coming up through the foyer. So we're currently on the second floor. This will eventually look down, there'll be a railing here, and it'll look down over the top of the great room. There's a large beam that carries the entire roof load on it, and spreads that load to the two sides. The ceiling joists, in this case, are removed because it's a cathedral ceiling, and the rafters, which are those members right there, are 2x12 to have a lot of room for insulation. So there are different types of ceilings that you can have. You can either have a 9-foot ceiling, like this entire first floor has. You can have an 8-foot ceiling, like the second floor has. And then this house also has what's called a vaulted ceiling, so it's slanted. We are currently up in the attic of this house, and down below us are the ceiling joists that'll ultimately hold up the drywall on the ceiling for the second floor, and it'll also give us a place to put a lot of insulation there. So these are the ceiling joists, and then the ceiling joists, about a third down on the height of them, you place what's called collar ties, and that's this member right here. And it just keeps the roof from spreading. And then the framing at the very peak of the roof is called the ridge. We have an LVL that keeps the ridge nice and strong, and then also we have it posted up to keep it from spreading and keep it structurally sound. Here we have another important framing member up in the attic. This is where two roofs come together, and this is called the valley. And you can see again, it's an LVL, and that'll stay nice and strong for the life of the house. And here we're just planning ahead for the next phase. The roof and the shingles are already on this house. So prior to placing the roof, we run the plumbing vents up through the roof so that the roof can be finished right up to it. I'm here actually in a future closet, and we're just planning ahead. We have sheathing on all the walls that back up to like a storage area in a roof behind it. And what that does is it cuts down on airflow later on when the house is all insulated, and it prevents air from moving, reducing your R value. So this is the framing member that goes underneath the valley where the two roofs converge, and you'll see again that it's an LVL that carries lots of weight. Also here we have the accesses to any storage areas. We put doors there, and if this is a finished area, it'll be a exterior door that's gasketed to once again cut down on air infiltration. So eventually the drywall, which will be the finished product on the ceiling, gets attached to the ceiling, and wherever we don't have a ceiling joist to nail the drywall to, we put what's called a nailer attached so that the drywall will go on there and you've got something to screw into. So obviously in this house the windows and doors are not installed yet. They're actually going to be installed later on today. But before they install the windows, you want to make sure that even under a high wind with blowing rain situation, that a window will be weather tight and you're not going to have any water getting into the framing. So before they place the window, they're going to put some ice and water shield across the bottom, actually around all four sides, and then down over the flashing on the outside. And ultimately, once the siding's installed, along with the drip cap it'll be able to shed all the water and not let any water infiltrate into the framing. We're now on the exterior of the house where the sheathing is placed. We use what's called a zip system. It has a 30-year warranty, and what you do is you put the sheathing in and then you put this tape on, which is incredibly strong, and it cuts down on drafts and makes your house a lot more efficient. Underneath the shingles, we have what's called ice and water shield. And you can see right here where it adjoins that wall, the ice and water shield, which is the black felt that you see above the flashing, and that runs up on the wall. That'll cut down any leaks that would happen during the winter during ice dams, and just make for a much better job. Over top of the ice and water, you have flashing, which is run down in layers on top of the shingles, and that'll again prevent any leaks. So some of the elements of a frame include a gable, which is that reverse A that you see there, and that reverse A runs into the main roof, and then that's what's called a valley, where the two roofs intersect. There are also a lot of houses that have hips, which is an outside point where the two roofs would meet, but that element is not on this house. You'll also see where we ran a 2x8, a horizontal 2x8 on the garage, and then up above here where the bedroom will be. And that will be wrapped with aluminum at a later date for a nice style. It'll improve the look. Thanks so much for joining us, going over the framing stage of the house. Stay tuned for the next video that'll include the rough-ins phase, which will include the HVAC rough-ins, the plumbing rough-ins, and the electrical rough-ins.